Welcome to Embedded System course. What you will learn in this course. This course for anyone wants to learn how to design and develop embedded systems regardless of the educational background. This course would be great also for engineers, developers, and tech students. So what is a system? A system is a program that works based on some rules. As an example, watch. The purpose of this system is to display the time. The rules here are the needles should move in one direction, one of the needles should move every 1 second, and the other one should move every 1 minute, and so on. What is an embedded system? An embedded system is a computer system that performs a very dedicated function. If we divide the embedded system definition into two words, we will get embedded, to be embedded into a larger system, and system, which means software and hardware together. Computer hardware like processor, RAM, keyboard, mouse, monitor, and so on. Embedded system components. There are three layers in any embedded system. Hardware, which contains physical components on the chip like input, output devices, memories, processor, and so on. Application software layer. This layer has the code that performs the tasks and may have real-time operating system. The real-time operating system is an operating system that works like an intermediate layer between the hardware and the software layer, and it defines the rules like in the watch example. Embedded system constraints. Any developed system should keep three main constraints: the size of the memory, the speed of the processor, and the power limit. Embedded systems classifications. There are three embedded system classifications or classes. We have small scale embedded system, medium scale embedded system, and sophisticated scale embedded system. In the small scale embedded system, we can use a small sized microcontroller like 8-bit microcontroller or 16-bit microcontroller. The hardware is very simple and also the software. The C is the most popular programming language that can be used to develop such a system, and also we need to limit the power dissipation, and most of the tools that can be used here like assembler, cross assembler, and so on. In the medium scale embedded system, you will find more than one microcontroller, 16 or 32-bit microcontrollers. It has complex hardware and software. C and C++ are the most popular programming languages for developing medium-scale embedded system. The tools here are RTOS, IDEs, simulators, and configuration tools. In sophisticated embedded system, we can find very complex hardware and software. We can use high-performance platforms like FPGAs, and for the tools here can be developed by application programmers for a specific purpose. Processor. A processor is the most important part in any embedded system or also in any computer system. As an embedded system engineer, you should be aware of the internal architecture of the processor. There are two essential parts: control unit to fetch the data or execution unit to execute it. Microprocessor. A microprocessor is a single chip device and it is not a complete computer. It just has a CPU, which contains a program counter, an ALU, a stack pointer, and some registers. But to make it complete computer, we should to connect it with some other registers, ROM, RAM, serial, and parallel ports. But on the other hand, a microcontroller is a complete computer. It contains a processor and other peripherals. Also, there is an important part which is the GPIO or GPIOs. GPIOs can be used to interface your microcontroller with other devices like sensors and even with other microcontrollers. So to sum up, what is the difference between microprocessor and microcontroller? Microprocessor is a general purpose processor, contains no RAM, no ROM, no input-output ports. On the other hand, a microcontroller has CPU, RAM, ROM, input-output ports, and also timer and other peripherals. Embedded system applications are everywhere in household appliances like in television, refrigerators, CD players, video games, in the aviation industry, also in planes, and in cars. An automotive real example here, we can find more than 100 microprocessor. From small scale microcontroller or 4-bit microcontrollers that can be used to check your seatbelt for your safety, and other microcontrollers for the infotainment system, such as head-up display and dashboard devices, and also for powertrains